Hi everyone. In this demo, I'll show you how to use SigNoz to instrument and monitor a LangChain AI agent. We will run a trip planner chatbot, look at the traces generated, and then explore the dashboards on SigNoz Cloud. So let's get into a sample interaction of our app. Here is our trip planning agent. You can select a departure and an arrival. So this will be where you're vacationing, for example. So let's vacation to Tokyo. And then we'd set our check-in date as well as our checkout date. And here the AI agent under the hood is performing a bunch of tool calls, such as getting the flight tickets, getting the hotel bookings, getting the weather, as well as getting the activities to do in that location area. As you see, we have our trip plan details with flight information for the departure and the return flight, as well as the costs and details for those flights. The hotel booking, so in this case would be Park Hyatt in Tokyo. Price per night, as well as the price total for how many days I'm staying there based on our check-in and check-out date, as well as weather information and popular tourist activities to do over there. And we also have a chatbot integrated, so we can ask questions based on this data. So I can ask something like, what are the clothing I should bring for this vacation? As you can see, the agent has responded based on the weather and all these details. It suggests to bring lightweight tops, females' dresses, any accessories over here, and packing tips. I'll just thank the chatbot. Behind the scenes, the agent is making tool calls, parsing results, and assembling the itinerary. Let's see how to instrument this with SigNoz in our code. Okay. Let's jump into the code. Really quick before I get started on this, I want to say that we're instrumenting this using OpenInference, which is an open source LLM-specific framework for instrumenting and observing your LLM apps that's built on top of OpenTelemetry, which is the open source standard for telemetry collection. So this is a really convenient and easy way to auto-instrument your apps, and in this case, it would be auto-instrumenting your LangChain app. So here, via this OpenInference line, you would need to pip install that, and you would get this LangChain instrumenter, and you can automatically instrument your LangChain apps via that. As well as you would need a bunch of the standard OpenTelemetry packaging, trace, resources, these four right here. So you need to do those pip install. How we can set this up is essentially define our resource, which is in this case, we're going to name the service name as LangChain Agent App OpenInference. We're going to pass in the provider as a tracer provider, pass in the OTLP exporter, and here we're going to pass in our SigNoz cloud endpoint as well as a SigNoz suggestion key. In this case, I'm using a .env file, and I'm calling load.env at the beginning, so I get these in my OS environment as environment variables. And note that here I'm using US because I'm in a US-based server, but you would want to put that to whatever region you're in. Then we, like normal, set the processor, add the span as processor in the provider, and then set the tracer provider. And here is the easy part. Using our LangChain instrumenter from OpenInference, all we have to do is once we import that statement above over here, all we have to do is instantiate that object and call .instrument on this. What this will do is we'll get any of the prepackaged spans and traces that are called in LangChain functions, such as graphs, tool calls, agent-related items, and we'll trace them all very effectively and very visibly in your OTLP provider. In this case, it would be SigNoz. And in this case, that's all we need to do to get our LangChain app auto-instrumented with OpenInference. And under the hood, it's going to be OpenTelemetry. Now, whenever we call any LangChain functions, it should be automatically instrumented and be traced. And I will be showing you that next in our SigNoz Cloud platform. Now let's hop into our SigNoz Cloud platform and check out the traces that were generated from this sample interaction that I just demoed to you. As you can see in the traces view, we see a couple traces that we had recently run. Let's check these out. Over here in this trace, what you can see is the LangGraph agent has traced via open inference, a bunch of things that we can see. If you expand these, we can see that, or every query is surrounded by an agent section, all the tool calls, and an agent section at the end. This first agent section is the invocation of the LLM agent to actually determine what tools to use. So that takes the query from the user and decides how to call the tool calls and with what parameters to call them. So as you can see, it calls the call model. And this is essentially what I was talking about, where it calls in our case, the OpenAI model and passes in some system prompt that I had given it. This runnable sequence is the details of that start of the LLM model. We can see details about the prompt over here, like the input message, the input value, as well as details about the specific LLM model itself. As you can see here, we can get things like the model name, things like what tool call to call next, basically what the agent is going to follow in the following steps, as well as a should continue flag, which is basically an agent way of saying, should we continue on to calling tool calls now? As you can see here, there is some information that might be useful over here. Now we can see that 4 tool calls are being called. And if we expand each of these, we can see that there are very useful functionality for each tool. We can see here that the get flight tickets is being called, and we can see some values, important values from there, such as the output value and the input value, and the tool description. So in this case, you see the fetch the round trip flight tickets based on departure and arrival destinations and departure and return dates. The next tool call that's being called is get weather, which actually gets the weather at that location. And as you can see, we have the other two, get the hotel bookings and get the activities. What's interesting here is we can see the time it takes for each tool call. And we see that they're roughly about the same in this case. And we keep track of time for the entire query. So in this case, the entire query took 14.9 seconds, almost 15 seconds, with the majority of the time coming from actually the start of the agent, in other words, determining what tools to call, and the ending of the agent. So this last agent call is actually once the agent calls all the tools and gets the results, how does it display that information back in human readable format? So in our app's case, this information specifically, how is it displaying this? And at the end of the day, that's going to be a model also. And so that's why we call the agent at the end as well as at the beginning. At the beginning, we are determining what tools to call and how to call them from the user's query. And at the end, the call model again is with the runnable sequence, and we can see details about the specific model that's being used. This is taking that data that's retrieved from the tool calls and kind of embedding it into a human readable format that the user can easily understand using an LLM. So that's just some information about the traces that you can get, which is completely auto-instrumented by OpenInference with the power of OpenTelemetry and SigNoz. Now let's hop into seeing this data visualized with dashboards. Now let's check out the dashboards that I've created for our specific demo. If we go over here to the dashboard section on our cloud platform, we can see a LangChain Trip Planner agent. This is one that I created specifically for this demo. And now let's set this to the last 6 hours to get more data. And as you can see here, there's some very useful data that you might want to know for an AI agentic workflow, specifically in this case, our trip planning agent. We can see here that we get the latency or the duration for the P95 latency for our call model function. Remember that call model was called to essentially trigger the LLM at the beginning and after all our tool calls are called, to essentially get from the user query to determine what tools to call, as well as after the tools are called to determine how to kind of interpret those results and put them back and send them back to the user. We can see here there are some spikes in the data at around 11 o'clock. We can see that it spiked to 20 seconds, goes down, and kind of goes gradually up over time. This is super useful for just seeing how responsive your LLM is as an agent and really trying to understand metrics about how the user experience is. Because if you see these spikes, you can most likely infer that the user is probably having to wait a lot for the answer. We also get a tool called distribution pie chart. As you can see, roughly each tool call is being called the same amount, and this is naturally because every time you want to plan a trip, each of these tool calls are getting called about once, and that's why we can see roughly they're all about the same amount. We also get our input and output token count, and this is super important for tracking, obviously, token usage as well as pricing from your LLMs. As you can see, we have 36.7K input tokens and around 12.5K output tokens. Over here, we have these 4 charts of describing the durations for each of our tool calls. As you can see, they look very similar, and this is because we're hosting these tools locally right now with some dummy data for demo purposes, so that's why the charts look very similar. But in general, you can basically see each individual tool call, how is it performing, and how is it looking for the user. And this is super important because if we see spikes in one certain tool, we get, from a developer perspective, what to address in the system to create the least amount of lag for the users. Tools with a higher value on these latencies or durations will most likely need improvement to overall bring down the lag for the users. This can give us really good insight on really how to improve our tool calls that our agents are making. And lastly, we have an LLM model distribution. This is basically the distribution of all the LLM models that are being used throughout this service. So as you can see, the majority of it is being used actually by GPT-4o Mini, but we had some runs using GPT-4o Turbo, GPT-4o, GPT 3.5 Turbo, as well as GPT-o3. And that's a quick overview of how you can instrument LangChain agents with SigNoz. We saw how traces capture each tool call and how dashboards give us real-time observability. Try this setup for your own LLM apps, and you can get full visibility into what's happening under the hood, especially for agentic workflows with LangChain. Thanks, and have a good day.